We started off talking about waves, and then we started talking about light, and I recently said that light was, in fact, an electromagnetic wave. But how do we know that? How did people first learn that light was a wave? People guessed, but how did they know? Well, it turns out there's one really clear experiment that showed that light was definitely a wave, because light could do something that only waves can do, and that is something called interference. If you have a wave traveling along and you have another wave traveling along, we know that they can add together. That's how you get standing waves. If you have one wave doing this and another wave doing exactly the same thing, then they add together and you get a bigger wave. That's called constructive interference because both of the waves are what's called in phase. If they're going against each other, then they're out of phase and you get destructive interference, and so you get a very small wave. And what we've got here is a wave tank that can show you what happens when you have waves doing that. It's a water tank. It has two features. The first is it can provide you with unexpected sudden delivery of water onto expensive video equipment. And the other thing it can do is it can shine light through water where you're making waves, and so you can see a very clear picture of the interference pattern that you get. So what we have here is a pool of water. We've got a red bubbly thing going up and down inside the water. And so what that's doing is it's causing waves to spread out from that bubbly thing, and you can see them projected with the light just as shadows on the paper down here. And so the regions of high and low water act exactly like the lenses we talked about last time, and so they bend the light, and that's what gives us these lovely clear shadows down below. We can change the frequency of the wave by changing the frequency at which the bubbly thing goes up and down the water, and because the speed of the wave doesn't change, that means the wavelength has to get short. Because of the limited frame rate of the camera, it's kind of hard to see that when there's traveling waves, but you can see in the top right hand corner there's a standing wave where the wave is being reflected from the edge, and there you can see that the wavelength has got shorter. So what happens if I add a second red bubbly thing to our machine here, and then I'm going to have two sources of waves in my water, and so both of those waves are going to be spreading out from different points. If they're spreading out from different points, then we're going to have two waves coming together. Let's see what that does. So what we see is the two waves add together to give constructive and destructive interference in a pattern. And this pattern is called an interference pattern, as the two waves interfere with each other. And if you look extremely carefully, you can see there are some parts of this wave surface that are going up and down, and some parts where the water is actually still. And what that means is there are places where you always get destructive interference, and there are places where you always get constructive interference. That's easy to explain if we go to a diagram.